Pluto is a distant and puzzling, relatively smaller planet that was once part of our solar system's planetary family. However, recent surprising revelations by renowned astrophysicists Neil deGrasse Tyson and Michio Kaku have brought Pluto back into the spotlight. They proposed an astonishing discovery. Pluto may be on a potential collision course with Neptune. But how could this happen, and what would the consequences be? Are we witnessing a fascinating cosmic anomaly, or is there more to this impending clash? Join us as we explore the possible outcomes of a Pluto-Neptune impact. Pluto, once classified as a planet and later redefined as a dwarf planet in part due to its peculiar orbit, remains a subject of ongoing study and fascination within the scientific community. According to recent data from leading scientists, Pluto's orbit is alarmingly close to Neptune's, prompting concerns from both Neil deGrasse Tyson and Michio Kaku about a potential catastrophic collision between the two planets, which could pose a serious threat to Earth. But how is such an event even possible? Pluto's orbit around the Sun is unlike that of any other planet in our solar system. It takes an astonishing 248 years to complete a single orbit. Since its discovery in 1930, Pluto has yet to complete a full revolution. But the intrigue doesn't end there. Pluto's orbit is characterized by its highly elliptical shape, significantly deviating from the near-circular orbits of the major planets. Adding to its complexity, Pluto's orbit is tilted at 17 degrees to the ecliptic plane, making its path far more extreme compared to other planets. This tilt and the elongated nature of its orbit further complicate its orbital dynamics. One of the most captivating aspects of Pluto's orbit is its intersection with Neptune's path. For roughly 20 years in each orbit, Pluto actually comes closer to the Sun than Neptune, defying what we might expect from their relative positions in the solar system. This raises the natural question: why hasn't Pluto collided with Neptune? The answer lies in the gravitational influences of other planets. The study of Pluto's orbit began soon after its discovery, as astronomers sought to understand its unusual path, which contrasts with the relatively flatter orbits of the other planets. Pluto's path stood out due to its steep tilt and stretched shape, and the mystery deepened with the realization that Pluto's orbit indeed crosses Neptune's. Despite these complexities, the stability of Pluto's orbit is a testament to the intricate mechanics of space. The three-body problem in space, predicting how three objects like Pluto, Neptune, and the Sun interact with one another due to gravity, demonstrates how their orbits affect each other in a complicated manner. It's akin to predicting where these objects will go based on their starting points and gravitational pulls. In Pluto's case, this problem highlights the intricate interaction between the orbits of Neptune and the Sun. Terms like libration and resonance, along with VSK oscillation, are central to understanding this interaction. Libration, in this context, refers to the way Pluto and Neptune avoid collision by maintaining at least a 90 degrees spatial separation when Pluto crosses Neptune's orbit. This distance is crucial in preventing their paths from intersecting. Resonance, on the other hand, describes the vertical movement of Pluto as it follows its orbit, ensuring that when it comes closest to Neptune or any other large planet, it remains above their orbital plane, providing an additional safeguard against potential impacts. Another important concept is the VSK oscillation, named after the researchers von Zeipel, Kapteyn, and Lindblad, who studied the gravitational forces between celestial bodies. This oscillation explains how Pluto, Neptune, and the Sun influence each other through gravity, affecting Pluto's movement. Despite Pluto's seemingly erratic path, this oscillation ensures that its orbit remains stable over incredibly long timescales, even billions of years. This means that Pluto's journey around the Sun follows a type of order, even if it seems unpredictable. Predicting future events in space, especially involving violent orbits like Pluto's, presents immense challenges. The inherent unpredictability of these systems means that long-term predictions are often riddled with uncertainties. While mathematical models are powerful tools for understanding and forecasting the behavior of celestial bodies, they also highlight the limitations of our predictive capabilities. These models depend heavily on initial conditions and the complexity of the interactions they simulate, meaning that even small errors can lead to vastly different outcomes. This unpredictability emphasizes the constantly evolving and dynamic nature of the universe. The more we learn about space, the more we realize how much is still unknown. The case of Pluto reminds us that our understanding of the universe is far from complete. Understanding the gravitational effects of the giant planets on Pluto's orbit offers valuable insights into the broader dynamics of our solar system. It demonstrates how the presence and position of each planet can influence the stability and behavior of other celestial bodies. So, why are prominent astrophysicists now expressing concerns about a potential collision between Pluto and Neptune? Despite all the forces preventing such an event, Neil deGrasse Tyson, a leading astrophysicist and a key figure in reclassifying Pluto as a dwarf planet, provides an intriguing perspective on the mysteries of our solar system, especially Pluto's case. Tyson views the renaming of Pluto not as a demotion, but as an adjustment based on our growing understanding of the solar system's many bodies. He sees the complexities of Pluto's orbit as a reminder of how much there still is to discover about space. Tyson's work emphasizes that as we uncover more about space, more questions arise, pushing us to explore further and refine our understanding. Michio Kaku, another respected physicist and futurist, offers a complementary view of the mysteries of space, focusing on the often chaotic forces that shape our universe. Kaku is known for his ability to connect complex scientific concepts with visionary ideas, making him a key voice in discussions on celestial mechanics and the broader implications for humanity. Kaku emphasizes the importance of continuous observation and advanced modeling to predict and understand potential astronomical events. He sees the interactions between celestial bodies as an area of study with not only academic significance, but also practical consequences. The potential collision between Pluto and Neptune, for example, isn't just a theoretical scenario, it's a reflection of the violent and dynamic nature of space. Kaku's perspective urges us to consider the broader implications of such events, from their impact on our understanding of the solar system to the potential need for future space interventions. Both Tyson and Kaku stress that space is a realm of boundless discovery and our current understanding, though significant, is still limited. Their emphasis on the need for ongoing exploration and advanced modeling reflects the evolving nature of space science. They highlight the importance of not only understanding celestial mechanics as they are now, but also anticipating how they may change in the future. The potential Pluto-Neptune impact scenario serves as a case study for the broader challenges and opportunities in space exploration. It underscores the need for effective scientific inquiry, advanced technology, and a readiness to revise our understanding as new information emerges. For Tyson and Kaku, the mysteries of space, as exemplified by Pluto's orbit, are a call to action for the scientific community and humanity at large to continue pushing the boundaries of our knowledge. There is a general scientific consensus that for the foreseeable future, Pluto and Neptune's orbits remain stable due to their mean motion resonance and the various gravitational forces acting on them. Therefore, a direct collision between Pluto and Neptune is highly unlikely. However, the complexities and potential perturbations in their orbital dynamics mean that astronomers must continue monitoring and studying these celestial bodies to better understand their long-term behavior and any potential risks. While the possibility of a Pluto-Neptune collision is largely theoretical and considered improbable with our current understanding, it highlights the importance of continuous research and observation in space science. Advances in technology, including more advanced telescopes and virtual simulations, will allow astronomers to refine their models and predictions, ensuring we stay abreast of the dynamic nature of our solar system. Tyson's perspective on Pluto's reclassification and Kaku's focus on the unpredictable nature of celestial mechanics both underscore the need for ongoing investigation and a flexible understanding of our universe. The potential impact scenario serves as a reminder of the dynamic and complex interactions within our nearby planetary system. It ultimately calls for continued research and observation to keep pace with the evolving universe. Pluto continues to captivate scientists and space enthusiasts alike with its distant, mysterious nature. While its status as a dwarf planet has long been debated, its unique orbit and peculiar characteristics continue to engage researchers.